Hi guys, welcome back to my channel. It's me, Darlene, and this is all-in-one notebook channel. So for today's video, we will going to solve quadratic inequality in one variable. So I have an example here, which is x squared plus 7x plus 12 is greater than 0. So in solving quadratic inequality, the first step is to change this inequality sign into an equal sign. So x squared plus 7x plus 12 will going to be equals to 0. Then the second step is to solve this equation by factoring. So the factors of 12 could be 4 and 3, so that if we add it, the sum is 7. So x plus 4 and x plus 3 is equals to 0. Then we will equate these two factors to 0. So x plus 4 equals to 0 is x equals to negative 4, and x plus 3 equals to 0, so x is equals to negative 3. Next, we will plot the points corresponding to negative 3 and negative 4 on the number line. So let's make a number line. Zero, negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4. So here is our number line. So we'll plot negative 4 and negative 3 in the number line. So negative 4 here and negative 3. So we will set 3 intervals here, and they are negative infinity less than x less than negative 4, and negative 4 less than x less than negative 3, and negative 3 less than x less than positive infinity. So here it is. Now we will test a number from each interval against the inequality. So any number from negative infinity to negative 4, we will get one number so that we can test it if that inequality is true or not, or the x value rather from that interval. So between negative infinity and negative 4, we will choose negative 5 or negative 7. Okay, so let's try negative 7 if x is equals to negative 7. So our quadratic inequality was x squared plus 7x plus 12 is greater than 0. Then we will substitute negative 7 in the x's. So negative 7 squared plus 7 times negative 7 plus 12 greater than 0. Negative 7 squared is 49. Positive 7 times the quantity of negative 7 is negative 49, and positive 12 greater than 0. So 49 minus 49 is 0, plus 12 is 12. 12 greater than 0. So 12 greater than 0 therefore is true. So this is a true solution. Next, we will get a number between negative 4 and negative 3 to test this interval. So let's say x is equals to 3.6. So our quadratic inequality is x squared plus 7x plus 12 is greater than 0. We will substitute 3.6 in the x's. So 3.6 squared plus 7 times 3.6 plus 12 is greater than 0. So 3.6 squared is 12.96 minus positive 7 times 3.6, sorry, negative 3.6 rather, so negative 3.6. So positive 7 times negative 3.6 is negative 25.2. Copy positive 12 is greater than 0, so 12.96 minus 25 minus 2 rather is negative 0.24. Sorry, I'm wrong. So 12.96 minus 25 minus 2 is negative 12.24 plus 12 is negative 0.24 is greater than 0. Therefore, it doesn't satisfy the inequality, so it is false. Next, let's try numbers between negative 3 and the positive infinity. So, example, let x equals to, let's say 1. So, our quadratic equality was x squared plus 7x plus 12 is greater than 0. Substitute 1 in the x's, so 1 squared plus 7 times 1 plus 12 is greater than 0. So 1 squared is 1. Positive 7 times the quantity of 1 is positive 7 plus 12 is greater than 0. So 1 plus 7 is 8 plus 12 is 20 is greater than 0. So therefore the equation was satisfied and it is true. We can make another number line because the solution in each intervals was shown, and we will exclude this part of the interval because it doesn't satisfy the quadratic inequality. So we will make another number line. 0, 1, 2, 3, 4, -1, -2, -3, -4. So we'll plot -3 and -4. Note that hollow circles are used in the graph to show that -3 and -4 are not part of the solution set. So because interval -infinity less than x less than -4 is true, then we will shade this part. While the interval -4 is less than x less than -3, we will not shade this interval. Let's jump in this interval, -3 less than x less than positive infinity. So we will shade this part because this part is true. So therefore the inequality is true for any value of x in the interval -infinity less than x less than -4 and -3 less than x less than positive infinity, and these intervals exclude -3 and -4. So the solution set of the inequality is x -4 or x greater than -3, and its graph is shown here.